So since we successfully configured the network communication and powering infrastructure for all our devices and the centralized station, it's now time to start configuring initial setup of the system from software point of view. Digitex Systems always delivers the system with extensive documentation, which actually describes the factory settings of our devices, meaning that since we always recommend to use static IP addresses for internal communication, the documentation clearly states the IP addresses of all the devices, meaning that we know the IP address of the Explorer Premium device and we know the static IP addresses of all the digital units used. For this setup, for this purpose, we know that we have connected two xWave digital accelerometer devices and one X-alarm device. So going through the documentation, we can easily see the IP addresses of those systems. So that's what we're going to show now. Looking at my documentation, I can see that one of my xWave digital accelerometers has address 10.10.10.21. So this is all again written in the documentation. So by simply typing that IP address into the browser, we are coming to the configuration page of the devices. First, we're going to show the configuration page of the xWave digital accelerometer device. Then, with slight differences, we're going to show the configuration page of the X-alarm device. Username, this is again protected website, so documentation also clearly states the username and password for this. So once we enter them, we're going to enter the device settings of this device. So we have a nice panel with three view, a panel on the left which is showing different menus, and we have a main panel where we see the main configuration. The first information that we will see the sensor serial number, which is actually a 24-character unique ID of each sensor, and that is actually the ID that we use to add this kind of a sensor to the system, which we're gonna show a little bit later. The device status is the first page which is shown here and actually shows the same information. It shows us the firmware versions of both the base, the wireless firmware, the serial number, the current device voltage that the device is operating on, the MAC addresses and the IP addresses, whether or not GPS module is disabled or enabled, and some additional information like total channels that are streamed out and the type of formatting of streaming of the data. What we see here is that this device has a total of 3 stream channels, which is a standard for 3-axial accelerometer, and we are streaming them in uncompressed format, meaning that besides this we can select different type of compression algorithms. In fact, Digitex most of the times uses its own proprietary compression algorithm, which provides very efficient streaming capabilities. The additional information that we see here is that the device is streaming, which is actually yes, of course, and we see the number which is continually incrementing, which is showing us that the number of stream packets till now are some number, which is actually the number of seconds since the last powering on of the sensor. This is the first step. The next step will be network settings, which is actually an extensive menu that allows us to make a configuration related to the network settings of the device. The first option is configuring the LAN network settings. I mentioned it at the beginning that all devices coming from the factory are actually configured as static IP addresses. So that's exactly what we are seeing here, meaning that we can see that this combo box is showing us the DHCP functionality of the network interface for this device is actually disabled, and we use static IP address in the same range that we have the Explorer Premium set it on. The other configuration are defaulted and should be used as per the documentation. The next option will be if this device is equipped with a wireless communication device, then this is the place where we set up the SSID and the username and the password in order for this device to connect to some wireless network. The next videos will be showing portable and ambient equipment, so we're going to explain this wireless settings configuration in more details. Same goes for the mesh Wi-Fi, meaning that all of our wireless devices are also equipped with mesh functionalities, and this is the configuration page where we can do the configuration of the mesh communication settings. If our device is equipped with a GSM device, this is where we do the initial configuration. Basically, these are the APN username and password information that are being provided by our local internet provider. So any country has a different. So having in mind when you use an alarm device with SMS functionalities, that we need to be aware of this information, which are always obtained locally. The next option is to configure the streaming functionalities of the device, meaning that how we would like our data to be streamed to the centralized unit called Explorer Premium. We have several options here, meaning that we can stream the data via Ethernet, via wireless, via mobile network, via mesh, or auto configuration. Auto configuration is a specific device which is used for portable equipment, meaning that for when doing ambient vibration measurement, actually field test, we often have a need to switch between wireless and wired communication. So the auto basically is developed for this purpose, so the sensor would automatically switch to the first available communication interface. For permanent installations like we're doing here, we always recommend to have the stream output to Ethernet, because that's how actually and the permanent installations are being done. The important part here is that we need to tell the sensor to which IP address to stream the data, and in this case, this is the IP address of our Explorer Premium, which I previously explained to be 10.10.10.10. We have another option here for over-the-air update of the firmware on the wireless module embedded into the xWave, but this can be done on more easier and flexible way, which can be explained later. The next configuration, the next setting here is related to the configuration of this device. Basically, depending on the number of modules, number of acquisition modules that each device can have, we can have here module 1 up to maximum of module 7. Usually, xWave as a digital accelerometer always comes with just one module. There's a 32-bit AD analog to digital converter module. So we're going to explain and see its settings here. The first settings are general settings, meaning that all of these xWave digital devices are equipped with internal triggering mechanisms, meaning that if we equip the device with internal SD card, we can also set up a trigger mechanism on that device also. This is handy and useful when we use the xWave as a standalone device, but most of the cases, the triggering part is done from the Voyager application, which we'll show a little bit later. So if we talk about the internal triggering mechanism for each device, then we have the settings here, meaning that we have several methods that can be used, including the STA versus LTA method, since this is a digital accelerometer, and all the appropriate parameters for setting up the trigger levels. The streaming section is showing us how the data are being streamed, and we have several options here, meaning that we can stream the data in uncompressed raw data format, or we can stream them in DGVLC type of binary compressed format. Also, there is another option that this device can stream the data using the mini-SID compression protocol, in fact using the STEM1 type of compression. So once we decide on the type of compression, Digitex and the factory always recommends to use the DGVLC, as this is the most efficient data transfer method in terms of performances. If we use the mini-SID type of streaming of the data, mini-SID compression, then we have a standard configuration parameter for each of these devices, which are well known for this type of a format. Then, important part is the synchronization. We have two options here. As I already mentioned, each device can be equipped, and usually they are equipped with GPS modules. But, for example, if we do an installation for building monitoring system, most often is the case that we do not have a very good GPS quality signal inside the building. So the recommendation is to use the DigiSync internal communication mechanism, which allows for all the sensors to be synchronous down to 1 millisecond together with the central acquisition station. If we select and we have an open and clear skies for GPS antenna, then we can always use the GPS synchronization method. We have another option here called stream buffer. What does this mean? This means that each of these devices is equipped with internal hardware. Actually, that's a RAM device which actually stores and keeps the data in case of network interruptions. This means, by simplifying this functionality into an example, would mean the following. Whenever we would have an interruption of the network communication, never any of the data will be lost, meaning that all the data will be stored internally in the memory of the digital device, and once the communication has been restored, all those data will be pushed to the centralized station. So this is a very efficient functionality of the xWave device, meaning that we apply for 100% of having all the data present, meaning no data loss at any setting, not even one sample lost in any case of network interruptions. So continuing to the next options, we have some generic options like the heartbeat interval, time interval, whether the device has a display or not, and the intensity of the LED. We always recommend to keep those settings to the factory defaults, and the system will be working smoothly at any time. The next important configuration to be explained is the actual configuration for the acquisition part, actually for the 32-bit analog to digital conversion. This is the actual location where we can configure different sampling rates from the device. So this information here is showing us that we can go as low as 10, as low as 1 actually, and up to 1000 samples per second. The different options are that because, for example, we could use 1 sample per second for simple RTD connected to an XSense device, and we can use 200 samples for a digital accelerometer. All those can be combined to the same system, so there should be no difference in the data at the end. The analog to digital converter of this xWave is a comprehensive model which offers for several options. Among them is the internal filtering of the data. As with the triggering mechanism, again with the filtering, we can use this option if we use the xWave device as a standalone device. Usually, and the recommendation is always that we always want to record data in raw format, meaning no additional filters applied. And during the analysis process of the data, during the seismic analysis, we can apply whatever type of filters we like during this process. So it's always better not to record data with any filters applied. The next is the configuration of the channels. So since this is a 3-axial accelerometer, we have configuration for 3 channels, channel 1, channel 2, and channel 3. And the important part is that we can enable or disable each of those channels, meaning that if we purchase a triaxial accelerometer, we can easily convert it to uniaxial if that's what the need is at that moment, uniaxial or biaxial. This is the actual location that we're gonna set up configuring and calibration data of the accelerometer devices. The next menu is called recordings and is actually telling us if we have an internal SD card module embedded for this device. In this case, we do not have, but if we would have an internal SD card, this is the place where we would see the both triggered and ring buffer data stored on the SD card from this particular accelerometer. This page is also used for downloading the data, again in the case when this device is used as a standalone device. Actions means that we have several actions here that can be performed on the device, meaning that we can simply reboot the device, or we can simply restore the device to the factory settings, or we can use another option that we can restore the internal configuration parameters to some previously saved configuration. In order to do that, we can always download the current configuration and keep it safely just in any case. Of course, we can always download the DXM, that's the extension of the calibration metadata file, which actually stores the calibration information for each of the channels used. The next configuration is actually real-life graph that is showing us the sensor, the real-time live data from the sensor. And if I can simply tap on the table, I can see that my channels are moving, meaning that I have a correctly set digital accelerometer. We can easily see here that one of the axes is actually oscillating around 0. That's actually the Z-axis, which is pointing vertically and using the Earth's gravity as the 0 value, which is actually 981 centimeters per second square. And finally, we have internal logs of the device, where we can browse to the history and see what kind of a error or action messages are being stored to the device. So we can easily go back and see what was happening in case we are experiencing some kind of a problems.